Welcome to the explainer that's going to completely organize your brain and, honestly, guarantee you ace your upcoming math exam on geometric transformations. If you've been staring at a grid filled with shapes, trying to remember exactly how they slide around or flip over without getting your coordinates totally tangled up, you are in the perfect place. We're going to take all that pre-test anxiety and transform it into total confidence.
All right, here's our game plan for test day. First up, core vocabulary. Second, translations. Third, reflections. And fourth, we'll cover verifying answers. Let's dive in.
So we're going to completely unpack this master information poster. Now look at all this incredible data. It might seem super dense at first glance, and well, it kind of is, but we're going to distill these complex rules into really easy to remember mantras that you can confidently use when that timer actually starts ticking on your test.
Okay, Section 1, Core Vocabulary.
First up, our playing field is the Cartesian plane. Now this is simply the coordinate system driven by the horizontal x-axis going left to right and the vertical y-axis going straight up and down. Just think of it as the stage where all of our mathematical transformations are about to perform.
Now listen, here's an incredibly easy place to lose points, so definitely watch out for this one. Always use prime notation. The original shape is just labeled with standard letters like A, but the new shape, the image after a transformation, absolutely needs an apostrophe. We say it out loud as A prime. This explicitly shows your teacher that your shape has officially moved from its starting position.
Finally, for our vocab, memorize what an opposite integer is. It's really just a number that is the exact same distance from 0, but with the opposite sign. So positive 4 just becomes negative 4. This specific concept is going to be your absolute best friend when we get to our flipping rules a little bit later.
Moving on to Section 2, Translations, or as I like to call it, the slide. Translating basically means we slide a point or a shape, either up, down, left, or right, on the Cartesian plane. The absolute key here is that the shape doesn't turn and it doesn't flip. It just smoothly glides over to a new neighborhood on the graph.
You know what's really interesting? It's how simple the math actually is when you break it down into a little matrix like this. Moving right or left directly changes your x-coordinate. Right means you add, left means you subtract. Moving up or down changes your y-coordinate. Up is adding, down is subtracting. It is literally just basic addition and subtraction disguised as geometry.
Okay, to secure full marks, I want you to write these exact 4 steps on your mental formula card right now. 1. Identify the original x and y coordinates. 2. Determine the math operations based on the slight direction. 3. Calculate the new coordinates and label them with that crucial prime notation we talked about. And 4. Graph the new image and connect the dots.
Let's actually simulate a test question right now just to make sure this is clicking. So grab a mental pencil. Where does point A, starting at 2 on the x-axis and negative 4 on the y-axis, where does it end up if we're asked to move it left 2 and down 3?
All right, let's see how you did. If you correctly remembered that moving left means subtracting 2 from the x-coordinate of 2 and moving down means subtracting 3 from the y-coordinate of negative 4, well, you landed perfectly on A prime at 0, negative 7. Fantastic work.
Section 3, Reflections. The flip.
Let's draw a pretty stark boundary between our two core concepts here. While translations just slide a shape around, reflections act exactly like a mirror. You're taking the shape and flipping it entirely over a specific axis, creating a perfect mirrored image right on the other side.
And here is the absolute golden rule for reflections. Whichever axis you reflect across, you keep that specific coordinate exactly the same. The other coordinate, that one flips to its opposite integer. It's elegantly simple, really. Reflect over x, keep x, flip y. Reflect over y, keep y, flip x.
Your exam steps are pretty similar to sliding, but the execution is definitely different. First, record the original vertices. Second, identify your axis and strictly apply that opposite integer rule we literally just talked about. Third, graph the new points using prime notation. And fourth, always do a final visual check to ensure it actually looks like a mirror reflection.
Let's do another quick flashcard to test your reflexes. What mathematically happens to coordinate A at positive 3, positive 4 if your exam asks you to reflect it over the y-axis? Take a second. Think about our golden rule. Let's check that answer. Since it's a y-axis reflection, the y-coordinate of 4 stays exactly the same. The x-coordinate of 3 becomes its opposite integer, which is negative 3. That gives us our brand new point, A prime, at -3, +4.
Section 4. Pro tips for verifying answers.
Okay, you've done the math, the shapes are graphed, but wait, before you stand up and hand in that test, let's talk about verifying your work so you don't lose silly points on calculations you actually fully understand. Make it a real habit to verify congruency, measure distance, and recalculate your coordinates. Let's look at how to apply each of these right before you submit your exam.
First, for translations specifically, do a really quick congruency check. Look closely at your final graph. Did your triangle accidentally shrink? Did it rotate slightly? If it's a true slide, the shape, size, and orientation must remain absolutely 100% identical to the original.
Next up, for reflections, use the distance measurement trick. Take your pencil and literally count the grid units from the original point right to the axis of reflection. Then, count from the axis to your new prime point. The mirrored point has to be exactly the same distance from the axis as the original. If one is 3 units away, the other must be 3 units away. Simple as that.
And for our final and perhaps most important check, coordinate calculation. Look, human error happens to the absolute best of us. Take an extra 60 seconds to carefully go back and redo the basic addition, subtraction, or integer flipping math for every single vertex. Honestly, just to be absolutely safe.
If you follow these clear steps and actually use these verification methods, you are completely ready to dominate this exam. But, it leaves us wondering. Architecture, graphic design, engineering, they all rely on these exact same principles. How will you apply these slides and flips to see the structures and symmetry of the real world differently once you step outside the classroom? Keep analyzing, keep learning, and hey, good luck on that test.